Historically, web architecture relied on monolithic applications on a central server. Modern stacks fracture that monolith into a decoupled architecture. Specific tasks now route to specialized providers. Edge networks execute compute, headless backends manage databases, and workspace providers process email. Beneath this network of specialized services, the legacy host still exists, operating as the foundational infrastructure. Between 2025 and 2026, legacy hosts rolled out massive infrastructure updates. But paradoxically, most of these updates are completely irrelevant to this stack. Massive host-side hardware upgrades, specifically CPU boosts and memory enhancements, have absolute zero impact on the application's actual performance. If compute and storage are entirely offloaded, we have to ask what actual utility the legacy host still provides. The legacy host is no longer the engine room. It serves strictly as a foundational DNS and identity ledger. Hardware metrics no longer dictate a server's value. API access and model context protocol integrations are now the only infrastructure metrics that matter. To architect modern systems, engineers must abandon hardware-based evaluations and focus entirely on a provider's automated routing capabilities. This specification sheet displays legacy hardware updates: a Gen 5 AMD EPYC processor, 40% CPU boost, and NVMe I/O. Evaluating these is a hardware fallacy. Front-end rendering that occurs entirely on the edge network, completely bypassing the host CPU. File storage and database queries similarly resolve on the headless backend, rendering the host's NVMe storage upgrades useless. The legacy server provides absolutely no compute power to this application. Instead, it maintains one strict singular responsibility: DNS traffic routing and identity verification. The host manages the exact routing pathways, specifically the A and C name records that point user traffic to the edge network. It also manages the identity pathways. The MX, SPF, DKIIM, and DMARC records verify the security of the enterprise email. Because compute is fully decoupled, the host's viability is dictated entirely by how securely it manages this DNS ledger. For decades, the historical baseline of legacy server management relied entirely on slow, manual, GUI-first operations, requiring tedious human navigation through complex menus. In April 2026, legacy hosts introduced REST API access for core infrastructure configuration. Management transitioned from clicking menus to executing programmatic API calls. By May 2026, hosts released an MCP server and official AI directives. These directives function through a skill.md file, acting as a native instruction manual that allows AI agents to understand the host's architecture. This enables a new developer workflow, issuing a natural language command to an AI agent directly within an IDE. You instruct the AI to point the app domain to the edge network. The AI parses the skill.md parameters to deduce the necessary infrastructure changes. It then autonomously executes the precise REST API call to update the DNS routing. Legacy hosting has successfully shed its static GUI origins to become a fully programmable, AI-first infrastructure as code platform. AI-driven infrastructure automation offers undeniable power and scalability, but deploying AI agents to manipulate core DNS routing introduces severe failure vectors. Within a decoupled architecture, the blast radius of a single error scales dramatically. The trigger event is often a single AI hallucination or a malformed API payload applied to a CNAME or MX record. This triggers an immediate cascading failure. Severing the DNS connection instantly takes down the front-end application rendering. Simultaneously, headless database authentication fails and enterprise email routing begins bouncing. A monolithic failure takes down a single machine. A decoupled DNS failure destroys all independent systems at the exact same moment. Modern stacks require a strict operational protocol for handling foundational routing. Architects must utilize AI strictly to generate the necessary DNS record parameters, rather than allowing autonomous deployment. API automation will dictate the future, but enforcing a strict manual verification step at the DNS level is mandatory to mitigate the automated blast radius. With the routing secured, the composable application architecture remains highly stable. Legacy servers are successfully pivoting to become critical AI-controllable infrastructure hubs if utilized correctly. Compute hardware specifications should be entirely ignored during infrastructure audits for decoupled stacks. The first true metric for evaluating a modern hosting provider is unwavering DNS stability and uptime. The second true metric is API granularity and comprehensive CLI tooling. The final, most critical metric is robust access controls to prevent unauthorized AI or AI manipulation. Providers must offer specific access controls, including IP-restricted API keys and granular, label-based SSH public key management. These specific security and permission updates are what make an automated AI pipeline viable and safe. Automation and MCP integrations are built to scale multi-tenant concity, not to expedite foundational project setup. AI agents and APIs define the future of cloud infrastructure, but manual verification of the core routing ledger remains the ultimate fail-safe for project survival.